This week we're exploring the technologies curriculum. Okay, just been developed for the Australian curriculum, and it's currently available on the Australian curriculum website and will be progressively rolled out to Australian schools over the next couple of years. Most states will be incorporating it in 2015. There are a number of schools that are starting to explore it this year, and most school systems should have incorporated it by 2016. So by the time you get out into teaching, hopefully with a position in a school, you'll have an opportunity and an expectation to be teaching the technologies curriculum. So let's see what it all is and unpack it in a bit of detail. So the technologies learning area is a brand new curriculum for Australia. And it's the first time we've had a new curriculum since the introduction of geography in the 60s. And in particular, digital technologies will be very new. We've had technology or design and technology in the curriculum for about almost 10 years now, since the Melbourne Declaration by all the state ministers decided that technology or technologies would be one of the key learning areas for Australian students to learn. But now that we've had the Australian curriculum put into place, the technologies learning area is being established within the Australian curriculum, and for the first time digital technologies and design and technology will both be subjects within the technologies learning area. So why do we have students learn about technologies? It's an interesting question because our curriculum is crowded, and putting new material into our curriculum is a serious decision to make. We don't want to overburden students and of course teachers with having to teach too much, because then we teach everything in a very shallow way. However, there's a number of different advantages for students when they learn about technologies, and in particular different ways of thinking about the world. And that's probably the key aspect of technologies education, providing students different lenses on how to actually view the world and interpret their interactions with the world. Just as with science, you've got a key lens, the scientific method, and being scientifically literate, you see the world differently when you understand the fundamental concepts of science behind the world, and likewise with mathematics and with geography and history. So, as with technologies, there are different ways of viewing the world when you have a deeper understanding of the technologies and how they work and how they contribute to our interactions in the world. So that's the real crux of technologies education. Now, there's a whole lot of practical applied aspects that we're going to focus on, but fundamentally, to be a really good teacher, you'll be teaching students at the level whereby they're gaining new perspectives on the world and ways of actually engaging with problem solving and with career choices, and just generally how they address issues in the world and how they perceive what they can and cannot achieve in the world through the lens of their understanding of the technologies. So the technologies education, as I mentioned, is broken into two subjects: design and technologies, in which students use design thinking, which is their lens on the world, and technologies to generate and produce design solutions for authentic needs and opportunities. So really a lot of problem solving and project-based learning, where students address a particular problem that might exist or you may provide them with to solve, or they might go out and actually try to identify a problem themselves and then solve it. And we're going to talk a lot during this course about different project-based learning and problem-based learning approaches that you can incorporate into your teaching to allow students to engage with that. And then there's digital technologies, in which students use computational thinking, which is probably a new word for most of you, and information systems to define, design, and implement digital solutions. So here, we're also solving problems and looking at different aspects of the world and different ways we can improve society or our own interactions with others or with different other technologies and so forth. But we do this using digital technologies. So design and technology incorporates all technologies. And next week we're going to start off with looking at what actually are technologies, and just how far into the past have we incorporated technologies. Of course, a lot of people think of them as the latest thing, like the iPad or the mobile phone and things of that nature. But technologies go all the way back to the invention of fire or flint knives, and all the way through to our current technologies today. But throughout all that, it's included things such as writing, even language can be considered a technology, and also certainly books and other artifacts. But we'll talk about what it actually means to be a technology and what's then incorporated into this particular learning area and what's not. So, we'll be looking at traditional, contemporary and emerging technologies that shape the world in which we live, but also allowing students to actually create new ones, or at least change existing ones so that they can be repurposed for new uses. And that puts a lot of challenge on teachers to incorporate that, because you may not be particularly technologically literate yourself and engage with those, but you need to be able to facilitate that with your students. Just as you may not be particularly mathematically or scientifically literate, but you certainly need to be able to incorporate into your lessons opportunities for students to become that way. And not just that, but also to enthuse them and engage them. Okay, in your class, maybe the next student that cures cancer or comes up with an engineering solution to get us to Mars, or things we haven't even thought about as possible. And it'll be up to you to provide that framework in which they can develop those gifts and attitudes towards technologies, as you will for your other subjects. So, technologies by their nature is a practical-based subject. Yes, there's a bit of theory in there, but really it's just theory that supports the practical application of problem solving and creating project solutions, etc. You wouldn't teach, or you shouldn't teach, technologies purely from a theoretical perspective. There's a whole lot of advantages to doing projects and experiments and problem solving and prototyping and evaluating different situations and tools and techniques. And we're going to explore this subject, or these subjects, from the perspective of problem solving and project-based learning as a pedagogy, rather than direct instruction or purely theoretical based instruction. Okay, so there's lots of things you can read there about the rationale behind the subject. There's also a bit being put in about ethics, and particularly about the social and ethical responsibilities of students when they engage with technology, particularly digital technologies. This is mostly because of concern about students getting themselves into trouble or difficulties through their use of digital technologies. It doesn't quite fit into the curriculum in terms of a project-based or problem-based approach or computational thinking approach, but because it is a significant issue in our society at the moment, and anything new is seen with a bit of fear and apprehension, and digital technologies certainly incorporate a lot of new elements, and so as a natural result there is some concern about how students engage with digital technologies, particularly when their parents, or in many cases even their teachers, don't really understand what they're doing. So we will be talking about some of those issues and aspects. But there are a number of particular aims that we want to ensure that students achieve throughout their 10 years or 11 years of compulsory engagement with digital technologies. And we'll talk about what's compulsory and what they have to do and what they don't in a little bit later. So investigating, designing, planning, managing, creating and evaluating solutions. So the key thing there is that they're doing it around solutions. So they're coming up with their own solutions to problems. And that's a pretty significant aspect. So they're going to investigate different problems, designing solutions to those problems or existing solutions to those problems and exploring those, then planning out potential solutions, managing the process of creating those solutions, and then evaluating how effective those solutions are. Probably the key things, certainly with design and technology, and to an increasing extent digital technologies, is that aspect of evaluation. One thing I do come down and try to impress upon you during this course is that unless a project can be evaluated and then improved upon, it's not really a technologies project. it may be an arts project, it may be a project suitable for one of the other learning areas, but it's not a technologies unit of work. So that's an important thing which I'll harp on a bit about during this course. But if they're just producing something, say a model or something that's aesthetically pleasing and so forth, say a model of a volcano. Now, if it's just a model and it doesn't work, then there's very little we can do to actually see how that could be improved upon. There may be some aspects you can assess it on and improve it, but in terms of students going away and designing a better volcano model, that's a very difficult thing to do. Now, if it's a working model, and where it's got to actually pump lava or pretend lava through a system, then that could be measured in terms of how effectively it does that, and then ways of improving that could be devised. It could be how evenly it flows when leaving the caldera of the volcano and the lava flowing out evenly around all sides. That could be something that could be measured and then improved upon. But it's simply a static model couldn't be measured, and so there's no real aspect that can be improved upon, and then it doesn't really fit within technologies education. Now, the vast majority of projects will, but there are a few, even some in the curriculum, which I'm struggling to come to grips with myself, but I'll try to help you through as we get to those, and together we'll try to work out just how we can incorporate project-based learning or the design process into those, particularly around some ones related to food. When you're coming up with a more effective selection of foods, then measuring those in terms of improving their nutritional value, etc., can sometimes be a little bit trivial unless you just select the very best ones and put those forward. Now, there are ways, though, of incorporating more complex understandings of creating menus and dietary requirements and so forth that can be then looked at and examined and then improved upon. Because one of the big aspects of determining whether or not something can be improved is whether or not something can fail. Does the solution that the students come up with, or the solutions that students might come up with, is it possible for them to fail in terms of coming up with a bad solution? One that simply does not meet the requirements. And that's a good benchmark to measure upon. Of course, that'll be another aspect we're going to talk a fair bit about during this course, the concept of failure and how important it is in any creative process. And that if there's no opportunity for failure, then there's really no real opportunity for creative work, or certainly for innovative work. And we'll talk about a whole lot of issues around failure and how to encourage that, or at least not discourage it in a classroom environment. Okay, a few of the others are creative, innovative, and enterprising. So three very important words there, which we're going to tease out as we go through, particularly next week. But the whole concept of being creative, and whether or not students are naturally creative or whether or not it can be taught. And we'll be exploring some of the ways that people suggest it can be taught and to be innovative and also enterprising. But there is some question as to whether or not it is something that's naturally imbued, but we can certainly create environments in which creativity can flourish. And likewise, we can create environments, and we may do that too often, in which creativity is discouraged in school environments. So we'll explore some of those aspects. Being able to make informed and ethical decisions about the role, impact, and use of technologies in the economy, environment, and society for a sustainable future. So lots of issues that we can look at in terms of what's the potential long-term impact of this technology. Yes, being able to split the atom and release a whole lot of energy has proven a very useful tool for creating a lot of power and energy. But that also led to the development of nuclear weapons. So there are always, in any new technology, good and bad things. Facebook has got a lot of great positive benefits, but it's also got a few negative ones. And likewise, other things that may be created might have impact upon our environment or our economy. Then we've got to ensure that students can engage confidently and responsibly in selecting and manipulating appropriate technologies. So basically making choices and coming up with the best possible not just solutions, but also the way they go about creating those solutions. And there's various things we look at there in terms of the materials that they could choose. They might be making a, well, very common one in primary years is making a little dollhouse. Yes, we could make the dollhouse out of paper or straw or brick or mud, and then we can apply various tests, such as pouring water on it or using a fan to blow wind on it and see whether or not it survives those sort of environmental conditions, very much as the fairy tale sort of encourages us to explore. But that's just one form of material. We could have students looking at a whole lot of different cloths and other materials for creating a shirt or a hat. Or if they're making a bridge, all the different materials that can be used for making a bridge in terms of wood or steel or concrete and things of that nature. So there's a whole range of different things, even foodstuffs and so forth. But that's one aspect of technologies. Data can also be considered a similar type of thing, whereby we can create various types of data. We could collect huge amounts of information, but sometimes it's more appropriate to collect things in different ways. And we're going to explore the process of data when we explore digital technologies. Then there's a whole aspect of systems. We'll talk more about this a little bit later, because systems is a really important concept in technologies education. This is how everything works together to achieve some sort of output or some sort of state. And we can make changes to that system, and that will have an effect. Then you've got the various components that make up our solutions, the tools we might use, and the various equipment items that students might need to learn how to use. From simple things such as using a hammer, through to using a 3D printer, or a lathe, or a sewing machine, or an oven. Okay, there's a whole range of different pieces of tools and equipment, but it can also be things such as computers or software that we need to be able to use in order to be able to create our solutions. Students also need to be able to critique, analyze, and evaluate problems, needs, and opportunities to identify and create solutions. And again, it comes back down to the fundamental problem-solving aspect of the learning area and how we focus on allowing students to go through that process. And it's quite an involved process. We will talk about this in coming weeks, but it's several steps and often done in an iterative process, which means we repeat it several times in order to gain the greatest value. And you'll find that in your assessment tasks. I often ask you to create a solution and then think about how it can be improved upon, and then create the subsequent solution based upon your evaluation of that first initial solution. But there are other steps that we'll also explore. Okay, so that's the general aims and rationale for the subject. We'll have a discussion about this in our weekly discussion, just about whether or not we do need the subject and whether or not it has certain advantages that maybe other subjects can't incorporate. Now, I have been involved in the development of the subject and providing advice and support for those that are developing it, so I am a little bit biased, but that doesn't mean you can't argue alternative positions. And in fact, I encourage you to do so, because through that process, we can explore the issues in greater depth. So, foundation to year 10. So what we used to call prep is in the Australian curriculum nomenclature called foundation. And all students will study the two subjects from foundation to the end of year 8. And then in years 9 and 10, there'll be optional subjects that students can choose from across all their subjects. But generally, design and technologies and or digital technologies will be made available for students to also study as part of their mix in years 9 and 10. Now this leads to the question of what happens in years 11 and 12. That's still up for discussion, and there will be eventually various subjects developed at an Australian level for digital technologies and designer technology. But for the moment, we'll have in Queensland, the Queensland Studies Authority already has some subjects that will generally meet the requirements. But eventually we should see guidelines for those subjects developed at a national level. So the whole idea of a curriculum document is simply to describe what we expect students to learn. whole lot of experts get together over many years, as has happened with this particular curriculum, and make decisions as to what we think students should learn across their compulsory schooling. And this happens at university level as well, although in our schooling we tend to be a bit more formalised and we have a lot of other external interests, particularly in more controversial curriculum areas such as history and English and so forth. But in the main, this tends to be the way things happen in K-12, and about every 5 years there's a major curriculum reform and a new curriculum is rolled out. Fundamentally though, as many teachers will tell you, it doesn't make a huge difference to what you actually teach in the classroom. Now, in this case, there probably will be a bit of difference because there's an expectation of doing digital technologies, but things in other subject areas such as mathematics or English or history, the majority of what's being taught doesn't change too much from year or from curriculum to curriculum. There is sometimes different emphasis and different focus, and over many, many years, sometimes decades, there are shifts in what's taught and how it's taught. But they don't tend to happen overnight with the introduction of a new curriculum. But each new curriculum does influence things to a certain extent. So in this curriculum, we break it up into various year levels, foundation to year 2, years 3 to 4, 5 to 6, 7 to 8, and 9 to 10, with various examples and elaborations provided for each of those. And then in both the design and technologies and digital technologies, there's 2 strands: knowledge and understanding, and process and production skills. Most curriculum documents end up having similar strands, basically theory and practice. They always have different names, but in the main, it always comes down to the same 2 areas: those things that you learn about and those things that you do, or you learn how to do. So this is a little bit more detail, and next week we're going to be exploring design and technologies in more detail, and in a few more weeks we'll focus on digital technologies. But here, under knowledge and understanding, in design and technology, we've got to focus on the use and development and impact of technologies in people's lives, and technologies and design across a range of technologies contexts. So this is where we explore how technologies and the design of these design processes can be applied in, say, agriculture or the industrial arts or home economics, etc. Then in digital technologies, under knowledge and understanding, we don't break it up into different areas of knowledge, such as, or in this case, context, as we call them. We have a focus on digital systems, which are the components of digital systems, so basically the hardware, the software, networks, and how they all work. So really how computers work and networks work and the software works, and how we represent data, and how we can actually store information on computers and then engage with that, either as images or as video clips or as text or as numbers, and how we actually incorporate that into our understanding of how computers really work. Then we've got processes and production skills. And design and technology focuses very, very clearly on a design process, whereby we create a solution by investigating, generating alternatives, producing one of those alternatives, evaluating it, collaborating and managing that process, and collecting, managing and analysing data through that process. So we're going to explore those in greater depth and look at a variety of different design methodologies that will help students engage with the design process. Digital technologies is somewhat similar, a little bit more refined in terms of it's defined by defining, designing, implementing, evaluating, and collaborating and managing. Not quite sure why we don't have collecting, managing, and analysing data in there, but really it's the same process, just a few different emphases that are different in the 2 subject areas. So that probably doesn't make a lot of sense to you just yet. But the real key aspect is that we have a set of knowledge that students have to learn about, and we've got a set of processes that students have to learn how to actually do. The key ideas. So there's a number of different key aspects that we want students to engage with. As I mentioned at the beginning, we want students to think about the world differently And these are some of the focus aspects there. The first one is the overarching idea of creating preferred futures. This is where we want to look at the world as it is today and make it better. And we do that through creating technological solutions or adjusting our use of technology to improve the world. So there can be short and long-term ways of doing that, but that's our fundamental approach in the subject. So we're trying to make the world a better place, and we're doing that through looking at how technology can be used to improve things. So improve our livability, our economic prosperity, our environmental sustainability, and other aspects. And often it'll be looking at the risks versus the potential impacts and making judgments as to whether or not the technology is appropriate to improving the world. Another big aspect is learning how to manage projects. Okay, students are going to be working through projects, and sometimes quite complex and extended projects, and being able to manage that process, organizing themselves, monitoring timelines, the activities that they're doing, the use of resources, etc., can be a complex and involved process, particularly for young students. But they can learn a lot through doing that, and things that they can apply to, well, not just other subjects in terms of how they do, but also just in terms of their life. But a lot of it will involve doing out time plans, managing risks, making decisions, controlling quality, evaluating processes, etc. Okay, then we get into the specific ways of thinking. Now the first one is systems thinking. Thinking about the world as systems. Okay, not just seeing, say, a computer as a specific object that does things for us, but seeing it as part of a much larger complex system. So a computer, particularly say if it's connected to the internet, is part of a much wider system involving many thousands, if not millions of computers. But a computer by itself also is a system where you've got generally some input devices such as mice, output devices such as screens, keyboards, which are other input devices. So there's a whole range of different components that all work together as a system. But we'll also look at that in terms of things such as an ecosystem is a system, but also a little farm that students might be running. That's a complex system whereby they've got to provide various inputs such as water and sunshine and nutrients, and they get certain outputs such as the things that they grow. But in order to make that system work, there's a whole lot of other little things that they might have to explore, such as the pests in the system that might be eating various aspects, or the nutritional aspects of the soil. So there's a whole range of different complexities that come about when you see problems and the solutions to those problems as being a focus on the systems involved. And again, we'll be exploring that in more detail as we go through the course. Then we've got design thinking. Okay, this is involving trying to come up with new designs, exploring them, being very creative, looking at lots of innovative ideas, exploring what already exists, other people have tried, and then coming up with our own solutions from that and evaluating those solutions and then improving upon them. So there's a whole range of different things that we can incorporate there. The examples given in the text here are designing a maze and trying to create the most efficient way for a robot to move through that maze, and then modifying your solution as you learn more about what's occurring over time. Then we have computational thinking. Now this is a new one and it's quite complex and we'll be discussing it in great detail. But computational thinking is seeing the world from the perspective of a computer scientist. So when you actually understand that a computer is actually running a program that's made up of a whole lot of little zeros and ones, and it does things based upon instructions occurring in the processor inside a computer, once you've got enough understanding of how computers work that you can see the world from that perspective, then the world becomes your ability to solve problems to do with computers becomes much easier. So as an example, when I went through my first degree at university, one of the tasks I had to do in one of my programming subjects was to write a word processor. So it was a very simple little word processor, and if you don't understand how word processors work, because most people don't nowadays, but you might understand how web pages work. And we have a language called HTML where we put what are called tags around different words and they make them bold or italic depending upon the different tags we put on either side of the words, etc. Well, word processors work in exactly the same way. But over the many years that I've been teaching, I've had a lot of discussions and problem-solving activities with business education teachers in particular, where they're teaching word processing. Now, these business education teachers know the particular word processors that they might be using backwards and forwards. They know all the different functions, all the different key commands that are needed to make the word processor do as they intend in great detail, far greater than I ever would want to. But they always come across problems where the formatting just doesn't quite work, or there's something happening that puts their formatting out and they don't know how to solve the problem. They've got a fantastic understanding of the software and all the different options available in the software, but they don't understand at a fundamental level that it's being run by a computer program that's putting tags around it and doing certain formatting. And from that very simple process back in my first degree of learning how to do the word processor and seeing the word processors and software from that perspective, I could generally solve the problems for them. And they would have no understanding of how I actually went about that process. Of course, they didn't have the view of computers and of word processors from that particular perspective. So that's one aspect we're trying to give to our students through computational thinking. Enough understanding of programming and how a computer actually works in terms of processing instructions and producing graphics onto a screen and things of that nature, so that when they face problems or when they're looking for solutions or coming up with new innovative ideas, that they can draw upon that fundamental understanding and see the world from a very different perspective from those that have simply used technologies as they've been provided to them. That we call ICT, where we simply use the tool to do things that we want it to do based upon what someone else has designed it to allow us to do. Digital technologies is about providing students with the ability to create their own tools or to modify tools to do what they want to do, not what the original intent of the tool necessarily was to do. And that's a fundamental shift in thinking about computing. So instead of seeing the computer as a black box which you can just use, and if it doesn't do exactly what you want, then so be it. Someone from a computational thinking perspective will say, no, I know it can do what I want it to do. I want to be able to modify it or write my own software or technologies to enable it to do that. And that's a very different and very empowering perspective on the use of technology. And that's what we want to try to achieve. I know it sounds tough. I know it sounds a big task to do. It is. But we've got a lot of process to go through to enable you as a teacher to scaffold that over many years and slowly develop that capability in our students. And as you'll see, it's not as difficult from a teacher's perspective as it sounds when we're first starting out. Okay, so within each of our subjects, we've got various band descriptions that describe what students should have learnt at various year levels. So F to 2, 3 to 4, etc. And we've got various content descriptions at each band that describe the knowledge and understanding and the skills and processes that students should be able to do. Now these are fairly brief and they're not particularly detailed. But under those, and we're going to look at them in a sec, there are what are called content elaborations. Or in fact, we're going to look at them next week in terms of digital technologies. We're not going to get into huge depth of the actual content of the curriculum this week. We're just providing an overview and the contextualization of what the curriculum's about. But for each of these content descriptions, there's content elaborations. Now, the content descriptions is what you have to make sure students learn, but they're very vague and general. Content elaborations provide examples of ways students can achieve the content descriptions, but they don't have to do, or you don't have to teach, all of the content elaborations. Okay, a number of teachers get very concerned when they first see the curriculum documents and they see all the content elaborations, all the examples, and think they have to teach all of those. You don't. They're there as guides to give you an understanding of what sort of things should be being taught in order to meet the content descriptions. Again, we'll discuss that when we look at the specifics for design and technology next week, and then in a couple of weeks' time, digital technologies. But I just want to clarify that now, and I'll probably have to clarify it a few times. Of course, it is a section that a lot of teachers get confused at. And then there's various achievement standards. Okay, this is what we want to have students demonstrate that they can do by each of the year level or each of the band levels. And you need to understand that these things students will build upon year after year. Now, initially, it's going to be a bit of a problem. Of course, if your students, say if you've got them in year 8 and they haven't done F to 7, then it's going to be a bit tough because the students are going to have a little bit of more difficulty achieving the year 8 standards, for example. Now, that's an interim problem. It will disappear after a year or two, as every student will have at least 1 year of previous studies, and then eventually students in year 8 will have 8 previous years of study. But that will take a number of years before we get to that stage. It's not too bad in that the curriculum has been written with that assumption in mind, so the expectations aren't incredibly high, but they certainly are higher than what they have been in the past. Finally, there's going to be a number of different words that we will be talking about and incorporating into our discussions, particularly of digital technologies, that you'll be unfamiliar with. There's a glossary provided, okay, at the end of this document, and you can then use that to reflect upon particular words and the meanings that we're focusing on during this course. But of course, you can always use Google or Wikipedia to get more detailed descriptions if you need to. So, as a brief summary of design and technologies, as we've said, you've got some knowledge, we've got your processes. We've got 2 things we want students to know about, how to use, develop, and look at the impact of technologies on people's lives, and look at the various contexts, which I'll describe now, because we can see them on the diagram. We can see engineering principles and systems, that's one context. Food and fiber production, that's another context. Food specializations, another context. And materials and technologies specializations. So that's the 4 contexts, and we'll be exploring those in depth next week. And then you've got the design process that students need to be able to go through when exploring those contexts. Okay, so what do I need to tell you about there? That just really elaborates what I've been talking about. Let's have a look at the specific contexts. So the first one is engineering principles and systems. Okay, it focuses on how forces can be used to create light, sound, heat, movement, control, or support in a system. So really we'll do things such as make bridges, create sound, it's really just basic engineering. Very similar to what you might do in science activities. And in fact, many of the same activity can be used to look at the engineering principles and systems learning outcomes and the scientific outcomes. They will have slightly different outcomes and slightly different processes. Remember, to do fully design and technology, students would have to be going through the design process, particularly the failure process or potential failure process and the improvement processes. Science, you'd focus on doing the scientific method and doing it as an experiment, and generally you're looking for a greater understanding of how the world works through looking at the scientific principles involved. Engineering, you're looking at a solution and how that solution can be improved upon. Not really trying to understand the fundamental concepts underlying the solution. Sometimes it helps, but really a really good bridge design is, being an improvement over an existing bridge design, is a great solution, regardless of whether or not you really fully understand all the physics involved. Although an understanding of the science and the physics involved can sometimes help you with your improvement to the solutions. So the first one is really engineering, and we're going to see lots of little activities. And if you look at the example ones I provided for your assessment, there's ones such as making a push-pull car for very young children, making a kite. There's a whole range of different engineering type activities that you can incorporate. The egg drop or the bridge building, okay, lots of little activities. Food and fiber production. Okay, this is looking at how our agricultural industry works and how we produce various items of food and items of fiber. It can be a tough one, and it's sort of a reasonably new area to be incorporating into design and technology, as is food specializations. So we're still looking at different ways to incorporate that in terms of the project-based and problem-solving processes. But creating a small garden or hydroponic garden, or growing some fiber and then looking at how the fiber can be turned into various items of clothing, for example, but also just exploring different fibers and looking at, okay, which ones are more effective for different solutions, say in making a piece of clothing. So there's a whole range of different activities that we can incorporate through our design process when we explore food and fiber production. And again, you'll be seeing lots of examples of that next week. Then we've got food specializations. Now this covers across a number of different learning areas, but in particular health and physical education, where they're also going to be looking at nutrition in that respect. Remember, design technologies though is looking at how we can improve things. So for example, coming up with a menu, say for a week, and then analyzing that in terms of the nutritional aspects, maybe the aesthetic aspects, and also the whether or not students actually eat it or how long the different foods last. So there's a whole range of different things you could explore and then look at how those things can be improved. But it's the improvement process which is part of the design cycle. And again, we'll explore different ways we can incorporate food specializations into design and technology. Then finally, we've got materials and technology specializations. So this is looking at a whole range of different things. It might be for communication or for housing or employment or medicine, recreation, transport, and then looking at how we could improve upon those to make better solutions. So it might be, say, a light rail system. How could we improve the light rail system to make it more effective in meeting various problems that might exist with the current light rail system? And that could be a challenge that you could give to students. Now they could either do that through a whole range of different prototypes, or they could make their own working model of a light rail system, or in the extreme, they could make their own fully working light rail system. Probably not an extensive one, but there might be one where you could make something that goes between two classrooms, for example, for transporting textbooks or resources between those two areas. So you can use some imagination to create the context for the learning activities and projects that students engage with. Okay, so then there's various types of design solutions that students will come up with, and there's three main types: a product, a service, or an environment. A product is probably the most common one, where they make something and then you test it against existing or alternative solutions for that product. A service is a bit different. This is where you're coming up with a different way of doing things. So for example, if you're going to have to make 200 cupcakes for a school fete, there are various ways of designing that process to achieve that. And that process can then be improved upon. So that's something that can be done in that respect. But it could just be a general service. So a service such as improving the local school environment. And that might be looking at a placement of bins or working out various ways of improving the local school environment through as a service for others. And that also brings us into the context of the environment, how we can make changes to or improvements to that environment. Okay, let's look briefly at the design, technologies, processes, and production skills, or in other words known as the design process. Again, we're going to be exploring this in a lot more detail next week, but just to briefly go through, generally we start off with an investigation, a research process whereby students look at the problem, look at what the needs are, look at the people it's going to affect and what their needs are, and then exploring what alternative solutions might already exist to that, what things people might have tried in the past, and then It might involve looking at different materials or different aspects of the solution that they're exploring, and basically finding out as much as they can, which will often lead them to creating a design brief. Of course, the next step is generating possible solutions. Okay, this is the creative process whereby we get students to create as many different innovative solutions to the problem as possible, and look at all the different impacts that those solutions might have, and select one of them, which will then go through to the producing phase, where they then create the solution, and then the evaluation phase, where they have to evaluate how effective that solution has been. Has it actually met or solved the problem that was initially decided upon? And through that, there'll be various collaboration and managing processes that can go on to make our development of the solution, or going through the design process, as efficient and effective as possible. Sometimes that's seen as a separate design challenge in itself, but it can also be incorporated into all design challenges. Now, the big thing is, what we very rarely do in schools, but one of the most effective ways of doing a design process is to then take your evaluation and use that to go back to the investigation phase and then come up with new solutions, or re-go through the generating phase, which you might choose one that you initially discarded based upon what you've learnt, or you may come up with a totally new solution based upon what you've learnt, then producing that new solution and then evaluating it as to whether or not it's been an improvement upon your initial solution. And that cycle can go on forever, but eventually, normally through time constraints of assessment and so forth, it stops and you have a solution that you then present. Now, you may get the idea, though, that most of the effort is actually in the process. And most of our assessment of students in terms of their learning, or most of the learning that occurs, and then our assessment of that learning, is through the actual process itself, not necessarily on the final product that's generated. Now, that's an issue that does have debate in various educational circles, but generally more and more we're now seeing an emphasis on the process rather than on the final product. Digital technologies. Again, just very briefly, we've talked about most of those aspects. The two main things is understanding the digital systems and the way we represent data, and then the design process for creating new digital solutions. What's new there that I haven't already discussed? Okay, so various production skills, collecting, managing and analysing data, defining problems and designing digital solutions, communicating ideas and information. Some of these are slightly different at various year levels. And again, we'll talk about this in a couple of weeks when we focus in on digital technologies. We've talked about computational thinking and the key concepts. Okay, the key concepts of computational thinking. Might briefly touch on these. Again, they won't make a huge amount of sense to you just yet, but the main concepts we develop in students are an understanding of abstraction, which is basically how we can look at the world and abstract complex systems to help us make sense of them. The processes of data collection, the ways we can actually collect data about different objects and items and processes and systems, and then once we've got them as data, we can then manipulate that data to make improvements or make use of that data or systems. Specification, this is where we look at a process and then specify what we want to have it do, which tends to then be an algorithm, which is a process for actually achieving something, and then the implementation, which is turning the algorithm into something that computers in particular can understand, which generally involves a programming language. But again, we'll talk about those processes in more detail when we focus in on that week. And then finally, not quite finally, digital systems, where we understand the hardware, the software, and the networks involved, and then the interactions, how people and digital systems interact with each other, how we interact with data and the processes, and the potential impacts upon sustainability and empowerment that our ability to create those interactions can result in. I know it doesn't make a lot of sense just yet. We've tried to make it more understandable, but unfortunately we are going to be incorporating a whole lot of new terms and concepts. That's why it's a new subject area. So there will be a whole lot of new ideas coming into this, but as we go through the course, we'll see lots of examples where we put these ideas into place and they'll start making more and more sense. And by the end of the course, things should hopefully be clear, or at least clear enough for you to start teaching in the area and slowly develop your capacity to develop students in terms of their computational thinking and design thinking and systems thinking. It's a journey. So here's some things you can read about in terms of getting a bit more understanding of abstraction, data collection, specifications, algorithms, implementation, etc. I won't go through those now because we will be focusing in more detail when we have our specific lecture on those concepts. Some of the design solutions that they might come up with are instructions for a robot, an adventure game, multimedia artifact or digital story or an animation or website. Okay, whole range of different activities, and you'll see a lot of those as examples in the assessment tasks that you can engage with during this course. Okay, so across Foundation to Year 10, generally Foundation to Year 2 is 5 to 8, Years 3 to 6, students from Years 8 to 12 years of age, and then 7 to 10, Years 12 to 16 years of age. A brief description of what students will generally engage with at those various band levels. And again, we'll go through these in greater detail when we focus in on the particular year levels. During this course, we're going to be focusing more on Foundation through to Year 8. We won't do too much on Years 9 and 10. Of course, it does start specialising, and for most of you, you'll be focusing in on the primary years. A couple other things you need to be aware of: student diversity, okay, and students with disabilities in particular, how they need to be addressed in terms of their engagement with both design and technology and digital technologies. Now, digital technologies in particular have had a long history of engaging students with learning difficulties, and most new digital technologies tend to be incorporated into supporting students with disabilities and their learning before they enter the mainstream. But that said, we do need to make sure that all students can engage with the activities that we incorporate into our classrooms, or we at least make modifications so that the students aren't disadvantaged depending upon their particular disabilities. You'll also have students with English as an additional language or dialect. In some cases, and it's actually happening in America in a couple of states, learning a programming language can actually be considered as learning a new language. So the process of actually learning to program, there's a little bit of research, not conclusive by any means, but students that are very used to using, or who are multilingual, who have engaged with multiple languages and an understanding of multiple languages, computer programming can be seen as simply learning a new language. It has a syntax and equivalent of spelling and grammar rules that you need to understand in order to make things work as intended, and students that are used to doing that have some advantage in that respect. And then of course you'll have various gifted and talented students. Now traditionally these ones have engaged a lot with particularly digital technologies projects, but also design and technology, whereby there's particularly through competitions, say robotics competitions or other competitions that students can get engaged with, and that's a good way of supporting your gifted and talented students doing extracurricular activities in that respect. But there's a whole range of curriculum aspects whereby you need to incorporate the needs of your gifted and talented students so that their learning is challenged. But you'll probably see, or hopefully you will see, that through this course that really good design challenges, which are the fundamental basis of our teaching of the technologies learning area, allow students from at all levels to explore opportunities. So a design challenge that may even be written for years foundation students might also be challenging for students in high school or even at university. The egg drop is a great example. Now there you could set that for foundation students and they can sort of come up with various solutions to try to keep an egg falling, say, a meter without breaking. But the same could be done with engineering students specializing at a university course, where they might, say, have to do it over 20 meters where it's dropping. So there's a whole range of different things that will be similar, but will challenge students from a whole range of abilities. But we'll talk again about that later in the course. Okay, general capabilities. These are the range of different knowledges and skills and behaviours and dispositions that we want students to develop across their years of education, but they don't fit neatly into any one particular learning area, and that they cover across multiple learning areas. So literacy has a whole range of general capabilities that we want to see developed in all of their learning areas. So whether or not you're doing something around science or around English or technologies, there'll be opportunities to develop students' literacy skills or capabilities. Same for numeracy, and also got ICT. Now ICT is probably the main one with respect to digital technologies in particular. And as again we'll talk about a lot during this course, ICT is your ability to use technologies as they already exist to do things with. So a word processor or a video editing, video editing piece of software. Someone has already written it and it's available for you to use, and you might use that in any subject area. But generally you have to learn about how to use it somewhere. So if we're going to do some video editing or some video production in digital technologies, then you might have to teach your students a bit about video editing. If, however, you're doing something in English with video editing, then you might have to teach your students about how to do it there. So no one learning area is responsible with teaching that. It's whatever learning area that students need to use that skill is responsible for making sure students have got the capability to do that. So that's a big shift. We used to have ICT subjects whereby we taught all of those fundamental skills. Nowadays, though, it's generally accepted that students will either be able to pick those up easily enough in any of their subject areas, or that they're naturally using technologies to the extent whereby formal instruction on those are no longer necessary. There's a bit of debate still around about that, but that's the way we've moved to. So you won't see things such as teaching how to use word processors or spreadsheets in digital technologies, or you shouldn't. You probably will for a little while. Of course, that's the approach we've had when we're teaching ICT. But as hopefully you're seeing in this course, there's enough new stuff to be focusing on in digital technologies to encourage people to get away from the teaching of ICTs. Other big area that has got a lot of importance for both designer technology and digital technologies is critical and creative thinking. Again, these are things that we want to develop in students across all of their learning areas, but there'll be certainly plenty of opportunities in designer technology and digital technologies to develop their critical and creative thinking capabilities. You've also got your personal and social capabilities, some important things there around online and online use of digital technologies and so forth. You've got ethical understanding about when things are right and wrong to do. And again, particularly around designer technology, when we look at the potential impacts upon technologies, upon the world and upon society and upon our environment, then they're things that will help develop students' ethical understanding. And then you've got intercultural understanding, where we're looking at the differences between cultures and nations and so forth. So they're the general capabilities. We've also got 3 cross-curriculum priorities. Again, these are not things that are done all the time or in any particular learning area, but they're things that teachers should keep in mind. So we've got Aboriginal and Torres Strait Islander histories and cultures. Now this doesn't mean we have to teach how Aboriginal and Torres Strait Islanders, for example, have used digital technologies. Okay, there are a few aspects whereby Aboriginal and Torres Strait Islanders are using digital technologies in ways that are somewhat unique, particularly around recording oral histories and creating, using technologies in that respect. So there's opportunities to incorporate that. And likewise in designer technology, looking at the different ways that our Aboriginal and Torres Strait Islander people have over many years incorporated the various foods and fibres of the Australian bush into their diets, and also different artefacts and tools that they might have created, like spears and woomeras and digging sticks and phishing traps and all that sort of aspect. So there's various things that can be incorporated into design and technology, and wherever possible, we are encouraged to incorporate these aspects as part of the cross-curriculum priorities. But likewise, the other priorities are our engagement with Asia. So looking at how various Asian cultures have incorporated the use of computers and technology, and also the various design artifacts that they've created over many years, and how those have been incorporated into their cultures and how we can learn from those aspects as well. Then you've got sustainability. Now, sustainability has got some specific mentions in our curriculum, particularly the design and technology curriculum, but it's one of our overarching cross-curriculum priorities is to ensure that students have got an understanding of sustainability and how we can actually create preferred futures that are sustainable and don't have a negative impact. Okay, links to other learning areas. Here we look at how design and technology and digital technologies can help the learning or be incorporated into the learning of other learning areas. Just as when you're doing English, there might be opportunities to incorporate some aspects of design and technology or digital technologies into English. Remember, this is not ICT, so it's something that needs to be integrated, but not seen as supportive. Okay, but say there's a whole range of different ways we can go about doing this, particularly when we're doing project-based learning, where a project might provide opportunities for learning across a whole range of areas. So it might, writing a design brief for a design and technology solution might be an opportunity to develop the students' English skills. Or doing some particular graphs and data analysis and understanding the data as part of digital technologies might also be able to incorporate into students' learning about aspects of mathematics. I've already mentioned science, and that there's lots of opportunities, particularly in design and technology, to overlap with development of scientific understanding. And likewise in digital technologies, because when you look at how real-world science is done today, and indeed real-world mathematics, it incorporates a lot of data modeling and virtual experiments and analyzing data and simulations, which can be incorporated into our understanding of digital technologies. Then you've got history and geography. Again, plenty of opportunities to cross over and incorporate projects there. The arts, and the arts in particular has got one that we'll mention again in a moment around digital, what do we call it? Multimedia. Because the arts has got a particular focus on multimedia, but design and digital technologies has also got an aspect of multimedia. But we look at things from a very different perspective. So from the arts, they're looking at it from an aesthetic, creative perspective. From digital technologies, we're often looking at it from an understanding of how digital imagery, like a photograph or a movie, can be created and manipulated through our understanding of the fundamentals behind the software that's used to create that. So understanding how Photoshop works, from an understanding of the computational processes involved, may allow us to make a better photo or better piece of artwork. But in digital technologies, we're doing that to better understand the technology involved, while the arts perspective aspect is doing it to better understand creating a piece of artwork and the artistic perspective involved. So you may do exactly the same task, and it may contribute to both, and that's perfectly fine. Then there's health and PE and economics and business. Again, there's all the learning areas, and each learning area has got opportunities to incorporate across others. And later on again in the course, we're going to talk about integration, which is particularly important in the primary years, where we try to integrate as much as possible, and we do activities and projects whereby students have got opportunities to learn about all of their learning areas when they engage with those tasks. Okay, and finally, hopefully finally, we're running out of time here, implications for teaching, assessment and reporting. A couple of things we need to make sure about is how we're going to go about assessing students' learning. And we'll talk more and more about that as we go through the specifics of the curriculum. But it's an aspect that is important. We tend to use a design process in digital technologies and design and technology, whereby we actually assess the process the students go through and not just their final product. Again, I've mentioned that a few times. But we also need to be mindful of safety, particularly in design and technology, where students might be using power tools or sewing machines or irons or ovens. So there is a range of potentially hazardous opportunities, and we need to make sure we not only manage that ourselves in terms of student safety, of course we're the responsible adults in those environments, but also have students become more and more aware and be able to manage their own safety. And then finally, animal ethics. Okay, and there is sometimes opportunities for animal ethics to be involved in, particularly in design and technology, where we might be looking at textiles or animals that produce various textiles, and also about animal husbandry, but even some simple things such as doing a very common activities to create an enclosure for ants or insects to live within, and looking at the system that's involved there and making sure they've got enough water and air and an environment in which they can thrive in. So that has some potential ethical issues in that if you fail in your project, it may result in the death or discomfort of the animals involved. And that needs to be considered. Sometimes it might be considered okay for ants, but it may not be considered okay for, say, guinea pigs or mice. So there's a whole range of considerations that need to be taken into account if you're exploring those sort of projects. So then we have the Australian curriculum connections. First one is design, and this is an area whereby design is looked at in both design and technologies, digital technologies, and the arts. Okay, all three of these areas have got a focus on design. And as students go through the curriculum and their learning, they'll have lots of opportunities to design. Now, design is somewhat different in each of the three, a little bit different in design and technologies to digital technologies, and both of those are again different to design in the arts. Food and fibre production is covered in various areas of the Australian curriculum, again, and same with food and nutrition. So there'll be multiple opportunities for students to engage with those concepts, but in design and technology in particular, there'll be a particular perspective on those from the design process, rather than from other aspects that might be evident in, say, the health and PE learning area. Home economics also covers health and PE and the Australian curriculum. There's a number of different concepts that are addressed in both, particularly around food and health. And likewise, information and communication technologies, the ICTs, where they're covered across the curriculum as a general capability, while in digital technologies there's certain specific aspects that are covered. And then finally, as I mentioned, multimedia is covered both in the arts, the media arts in particular, and in digital technologies. And there's a bit of a crossover, but we have different perspectives on the different learning outcomes that students achieve when they engage in using multimedia or creating multimedia objects. Finally now, the time allocations. Now these aren't, they're semi-official. These are the guidelines that were provided to the writers of the Australian curriculum in terms of how much time should be allocated to each of the different subject areas. So that when you come to plan your teaching year, how much time would you be spending on doing design and technology activities, for example, versus mathematics activities and so forth. Now generally there'll be a certain amount of allocated time and a certain amount of unallocated time. The allocated time is what's being defined here. This is what students have to show that they're doing. And you'll see that as we go up in the year levels, more and more becomes unallocated time, which means students have got options and schools can have options as to how much time is spent on various subject areas. So if we look down at design and technology and digital technologies, it's expected that in a year, students in years, well, it shouldn't be P to 2, it should be F to 2, will spend around about 10 hours on design and technology and 10 hours on digital technologies. Not very much. But to put it into context, it's about, or combined, it's the same amount of time as they would be spending on geography or on history. Now, as we go up throughout the years, there becomes an increasing emphasis on the technologies. So, for example, in years 5, they'll be spending combined 60 hours on design and technology and digital technologies. And each of those is sort of about the same, or combined, it's about the same as what they're, a little bit more than what they're doing in the arts, or in history, or in geography. And likewise, as it progresses up. So it isn't one of the major subject areas, certainly not as much emphasis put onto it as in English or mathematics, but these are the mandated times. This is what has to be done. Remember, schools have, at the early years, 28% of the time, and then towards the upper years, over 50% of the time, in which they can add additional time to various subjects depending upon the focus that the school wishes to have. So if the school decides, okay, we do want to have an emphasis on digital technologies, while we have to do 40 hours in year seven, we're going to make it 60 hours because we want to have a bit of a focus on that, and also so it fits more within our timetabling and all the rest. Timetabling becomes a big issue related to that, but that's something your deputies in your school have to worry about, and they spend a lot of their time working out the best mix of times available for different subject areas, depending upon student interest and the focus area of the school. So that gives you a bit of an idea of the technologies learning area. And then finally in your notes there's a whole series of glossary items that you can go through to see if you can understand some of the strange and arcane terms that we'll be talking about. So that's the technologies curriculum area. I know it's a lot to take on board at the moment. We are going to be breaking it down into various components, known as deconstructing in terms of computational thinking, and exploring what each of the different aspects of the curriculum and how it's going to impact upon your teaching and how you're going to plan learning activities to enable students to learn within the technologies learning area. So that's it for this time, and next week we're going to be exploring in greater detail the design and technologies curriculum.